Let's continue talking about our good friend sine of x. Last time we added in amplitude and period, which you can find from this b. The b is not the period. I'm not going to worry about what that is right now. And don't ascribe too much importance to this a and b. I mean, that's their a and b. A happens to match up with amplitude. B is frequency. Don't worry about what B is. So may have a parentheses around it. So remember we did that, and amplitude controls how high the function goes. Sine function goes. And B controls the period, how far out it goes this way. Normally it's 2 pi if B equals 1. But if B gets bigger, this gets squished down and the period gets smaller. If B is, you can think of that, if you make B 2, this is going to get to 2 pi when x gets to pi, so that cuts it in half. So if we're determining the period, if I was using P for period, it's 2 pi over B. So if we ever asked for the period, it's 2 pi over whatever this is. Now we're going to add 2 more things into this, and that'll allow us to describe pretty much any sort of sine curve. The other thing we're going to add is, I'm going to add in plus c. I'm going to, trust me when I make this parentheses a little bigger, bx plus c, and then the whole thing plus d. This d is outside of this. Alright, 2 more things we're going to add. We have amplitude. We have b, which controls the period. This d is going to control the midline. Basically, d is just another number we add on. And what's that going to do? Let me rewrite this. A sine bx plus c plus d. A controls the amplitude, B controls the period, D is just some number we add in. So let's say we had, let's say A equals 1, and we just had sine x, B equals 1, C equals 0. Suppose we had just f of x equals sine x plus 2. What does that look like? Well, that's going to be a regular sine curve, but it's going to have 2 added to everything. So where it was 0, it's now going to be 2. Where it was 1, it's now going to be 3. So it's going to go up here, down here. Where it was minus 1, it's going to be 1. And this is going to be 1 period here. Alright, so this is the new midline, and in fact we call D just the midline. It's you can think of these as oscillations, sort of like a spring going up and down as time goes by. It oscillates about this midline. This is the middle here, and this is going to be D. Alright, again, we just picked D because it A, B, C, D. We're just going through these. It has no special meaning. Alright, the last thing, that's pretty straightforward. If D were negative, it would be below the line. Typically, D is 0, and we just have our sine function, which oscillates about the x-axis. Alright, the last thing we're going to talk about is C, and C controls the phase shift. It isn't the phase shift, or phase, just phase. Sometimes called phase shift, and sometimes just the phase. Phase shift pushes this around, pushes the whole curve back and forth this way. Now let's see how that works. In general, I'm going to rewrite this. let's take this equation up here, and I'm going to factor a b out of this middle section. So this becomes sine of b, bear with me, x plus c over b plus d. Plus d. Alright, again, this d is separate out here. Now it's just sine of b of x plus c over b. You can see that if c over, well, what happens here is this c over b changes the initial x value. It's sort of added onto x. So maybe x started at 0, maybe c over b equals pi, and then x starts out as pi, and then when x gets to 0, the whole function gets to 0 when x equals minus pi. Alright. Phase shift is a little confusing, but we'll just have to learn to deal with it. It's not that important. We can always redefine x. You can say x starts, instead of starting at 0, starts at minus c over b, and then this phase shift goes away. But this sort of moves the curve back and forth. Let's see how that works in an example. Let's try f of x. We can do these for cosine too. It's the same thing, they just start at different places. Let's say sine of 2x plus pi. Alright, what is this function going to look like? Well, this is going to be sine of 2x. I'm just going to draw a sine of 2x first. Oh, this is all in parentheses too. If it wasn't, then that pi would be d, and that would be out there. And that would push the function up pi units. I'm just going to draw a sine of 2x. So the period for sine of 2x, period, which we'll call a capital P. Your book balks at picking things. It doesn't have a symbol for phase shift, so we're kind of stuck. Often some books use phi for phase shift, but I don't know. We'll just muddle through and not pick anything. So the period is 2 pi over this b. 2 pi over b. It doesn't matter that this pi is here. So this becomes 2 pi over 2. So the period is pi. So that means this function completes a whole circle, a whole cycle after pi. So sine, and you'll get to know this very well, it looks like that. And if this is sine of 2x, then this is pi. And we get another cycle out here. Often we'll just draw one cycle, but know that these curves go on off into infinity. Okay, so this is shifted over pi. I'm sorry, this has a period of pi, but this pi here shifts it over. And to find how much it's shifted over, the phase shift, we should have a contest to pick a letter for that, is C. Remember, this was C, and this was B, and this was A out here, which is 1. And then there's D out here, which is 0. Phase shift is C over B. I kind of want to put a negative sign here, but we'll just deal with that in a second. If this is positive, then it's shifted that way. If the phase shift is negative, it's shifted that way. There's two ways to say that. I could put the negative sign on the phase shift and say that this is negative that, or we could just say that it's shifted that way. In this case, the phase shift is C over B, which is pi over 2. and it's positive. So this gets pushed back this way, pi over 2 units. So this is pi over 2. Let's see, this is going to be minus pi. We want it shifted over minus pi over 2. Alright, the phase shift is positive pi over 2, which equals c over b. So this curve ends up being, we'll draw it as red, the same curve just pushed back. And it ends up like this. Alright? And it keeps going like that. So the same curve is just pushed back. Notice there's other ways to say this. This could be negative sine of 2x. See, this is sine of 2x. Here's negative sine of 2x. That's another way to say it. Also, we could have pushed it back a whole period. If we'd have pushed it back, if this was 2 pi, then this would have been pushed back a whole period. We get the same thing. Anyway, so this is pushed back. That's the phase shift. Sometimes you'll think this number here is the phase shift. No, that's just c. C is c over b. Sometimes you look at a problem and there'll be this b will be 1, in which case this actually is the phase shift because pi over 1 is the same as pi. But that's the phase shift c over b. If you let me go into Desmos.com for a second, we'll play around with these and I'll show you how they work dynamically. Alright, I'm going to do a sine of bx plus c, oops, try and stay consistent, plus d, whole thing plus d. We'll add sine b over x. So we'll add sliders for all these things. Alright, I'm going to put d down to 0. And this is nice because it dynamically shows you what's happening here. I'm going to put c at 0 too. So this is a equals 1, b equals 1. So this is sine of x. You can see it goes up here and it comes down. That's about 6 and a little bit more. That's 7. That's about 6 1/4. That indeed is 2 pi out here. Alright. It doesn't leave the pi in. Oh, there it does. Maybe you can see that. It says 2 pi there. So that's where it comes back up. It's a half a period at pi here. You can see 3.08, 3.14. A little farther. Oh, we went too far. Well, it's not going to let us. I don't have that fine motor skills. Anyway, what happens is A goes up and down. A controls the amplitude. You can think of when you're producing sound waves on your radio. As you increase the amplitude, the sound gets louder. Try and get this back to 0. Let's see, B is the period. As B goes to 2, see the period gets squished down. As the period gets larger and larger, it gets more and more squished. If we go the other way from 1, oops, we stretch it out. I don't want to go negative. Then we just end up flipping over. Alright, so we get the period stretched out that way. Back to 1, motor skills. And D pushes it up and down. So if D was 4, it oscillates about 4. Okay? It's a nice thing here. You can play with it and see what all these different things do. This is pretty much all we can do to a single sine function. This works too for cosine. We can push cosine up and down. Just cosine, when it starts at 0, it starts at 1. It goes down this way. You can phase shift. This was C controlled our phase shift. You can phase shift cosine so that it looks just like sine. There's something you can add to sine just to get cosine. We could graph the two over each other and see that they are indeed the same. So amplitude, B controls period, C and B controls phase shift, and D controls where the midline is. Alright. Pretty neat stuff. That's everything we need, and that's what we're going to cover now when we look at sine and cosine as periodic functions.